Hello everyone, welcome in. John here, staff software engineer, 10 plus years of experience. I'm the lead maintainer of Latterly.io, an open source educational platform that'll help you learn to code and land your first or next programming role. You can sign up for free and join the community, hundreds of engineers on the Discord. Hope to see you there. Today I'd like to evaluate this quiz feature, which I just found out about today. Neetcode has a quiz feature, and I'm hoping it's similar to the formation aptitude test, which is something that I used last year. I took advantage of the formation fellowship, and the aptitude test helps you qualify for the fellowship. Inside the fellowship, you don't really use this multiple choice experience, which I thought was disappointing. Maybe they will change that in the future, because I really enjoyed using this quiz as a means of pattern matching. So when it comes to Neetcode, technical interview preparation, one of the key things that you need to learn to do is to rapidly identify the optimal algorithm, and then code it, right? So coding is the second stage, and the fellowship really focused on practice interviews and getting the coding down, which is great, and that is important. And I do recommend the formation fellowship. But I thought for a sort of mental warm-up, this was a really great way to look across many patterns rapidly, where grinding through problems, you could take 20, 30, 40 minutes, even an hour, and really just get through a handful of questions, and you might not cover all the patterns that you could be anticipating in a real interview. So I don't know if that's what this Neetcode thing will do. I haven't done any of them yet. I've just brought the UI up. Let me see. I think you can see the UI. Yep. And so let's dive in together and see how this goes. I'm going to use the random mode. Given an interval array where I is start I, end I, return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. 1, 2, 2, 3, 3, 4, 1, 3. 1, 3 can be removed, and the rest of the intervals are non-overlapping. This means that these are exclusive rather than inclusive indice arrays. And so following the logic just from example 1, we can scan through the others, but following just from example 1, we would say these intervals are not overlapping. Although they join on the 2, they're considered not overlapping by the logic of example 1. And that seems to hold. Are these overlapping? No. I think that means I got it right because it's green. Given an array of intervals, okay, it's the same question. We're getting a new question. That's interesting. Okay, cool. So I'm getting 5 questions about this same question. That's probably cool. So it helps us think deeper about the problem rather than, okay. So since overlapping intervals will be adjacent, which operation can simplify the process of finding overlaps? You could sort. What about reversing the order of the intervals? That won't necessarily help, no. Shuffling randomly won't help, no. I think sorting will help. Good. If we iterate through the sorted intervals, how do we know if the current interval does not overlap with the previous interval? Between the start and end indices, does it capture either of the next nodes, is how I would say that. So if the end time, so we're going by time rather than node, that's fine. If the end time is less than the start time, no, that's not sufficient. If the start time is greater than or equal to the end time, oh, okay, we want to know that they don't overlap. If the start time is greater than or equal to the end time of the previous interval, they're guaranteed not to overlap. Yeah, I think it's this one. Let's read through C, but I think that's the answer. If the end time is equal to the start time of the previous interval. That's a weird situation. If the end time of the current interval is equal to the start time of the previous interval. I think that does also help. Sort of out of order, you would need to reverse, you would need to reverse the intervals, and I guess that's the wrong answer because That's assuming an extra step that we didn't affirm yet, so I'm going to go for B. Cool. You could use C, but you would need that additional thing of reversing the order, which we're not doing. When two intervals overlap, which should we remove? Do we want to do interval with the earliest start time? I want to do the wider interval. That's what I would prefer. The interval with the earliest start time, the interval with the latest end time, or the smallest interval? Well, it's not the smallest interval. What about the interval with the earliest start time? Okay, in this arrangement, they're in order already. In this arrangement, they're in order already. I wish I could go back, because this is like assuming a particular implementation. I worry if this graph is misleading me. So according to the graph, we would choose B. According to the graph, we would choose B. But according to the logic we described, that's not as clear cut. So let me think about the generic algorithm rather than the graph. So the start time on the second is greater than or equal to the end time on the first. I think I would still choose B. I think you could do A or B, but I'll go for B. And it's saying the optimal strategy is always to remove the interval with the latest end time. Yeah. I think we're assuming a particular implementation, but I'm okay with that. Nice to know that it agreed with the graph. I don't know if we can always do that. I'm remembering back to high school where we were taught not to trust the graph, to prioritize the words. All right. One of the things, I'm just going to briefly tangent. One of the things that's different about this aptitude test is you will actually have many code snippets. It's less of a word problem. So here we have our first code snippet. And in the aptitude test, you will sometimes be asked to fill in code expressions in an incomplete algorithm, which I really, really like. And that's a feature that's in the backlog for Latterly. But it would be nice if Neetcode just does that for me. To summarize, the below code will optimally solve this problem. What is the overall time and space complexity? Okay, so I don't need to fix or adjust the algorithm. I'm just told that it's optimal, and I'm just evaluating it. So interval sort is n log n, and then I want to iterate from start to end in the intervals, slicing off the first element. Yeah, it looks like n log n. I don't see a second loop, so I don't see a reason to square it. So I'll go for B. I mean, we can confirm the space complexity as well. So result is what data shape. Result here appears to just be a pointer, yeah? So where am I holding space complexity in? I don't actually see where space complexity n is held. Yeah, this is a bummer. Where is that space complexity coming from? So is it n squared then? I think this is the one that is... I might get this wrong. Oh, I guess the space complexity is coming from the sliced intervals, from start end. So here we create a subarray that's O, it's like O dot 5n, which is asymptotically O of n. So I feel good about that. Okay. You sort the intervals, yep, then you iterate the additional space. The space complexity is O of n because in the worst case you store all intervals in the input array. Yeah, and where do you store them? I think it's on this line for start end, and I think that's the one. Cool. That was fun. The submit is not working. Okay, I guess I don't need to do that, but I just did. And I told it not any. That wasn't helpful. Sorry.
Everyone.
Cool. Well, I wish it would just like ready up my next one. Let's do another one. Spiral matrix. Cool. So we're given an MN matrix. What is the correct order of traversal to achieve a spiral order in the matrix? Right, down, left, up. From left to right. Really, I think it's A just because of this first expression, but let's read it through. Rightmost, top to bottom, bottom from right to left, leftmost from bottom up. I think it's that one. Yeah. So after we complete one cycle, what should be the next step? We've completed a cycle because we're pointing up is the idea, and then we run into a scene element and just skip that direction. I think we repeat the same cycle, yeah? Yeah. So to traverse it, how many pointers do we need and what do they represent? Okay. Well, we need X and Y pointers, that's for sure. And then I was thinking to use like a scene set or to do a mask, but it's saying to only use pointers. So if we avoid a set or a mask, then we would have two more pointers. So the current position X and Y, and then the boundaries. Let's see. You would need all four of them, right? Up, down, left, and right on the whole current matrix to define the current submatrix. Could you get away with two? So let's just have a pointer that we add to the 0, 0. So one for each of top, right, bottom, and left boundaries of the current submatrix. No, that doesn't sound right. One for row, one for column, and one for diagonal traversal. No, I don't think so. Oh, that's an interesting idea. Maybe that would work. And then C says one for top, right, bottom, left boundaries and one for the center of the matrix. You don't need a pointer. In the implementation I'm imagining, you wouldn't need a pointer to the center of the matrix. So I think it's not C. One for each top, right, bottom, and left boundaries of the current submatrix. I think you could get away with A or B. The word need makes me think that you want to go bias towards a lower number because you only want to use what you need. In example 2, we have a rectangular matrix. So would a diagonal always work? I think the diagonal is equivalent to having 2 in the square case, but is it equivalent to having 2 in the rectangular case? No, it's not. If you picture a really long, say 3 by n, and where n is like large, then the diagonal, which guarantees that you already took care of the top left corner, would not show you how far to the right you need to extend. So I think we need to do 4. Cool. Given the Python code below for traversing a matrix in spiral order, what will be a potential issue when running this code in a non-square matrix? For example, consider 1, 2, 3. Okay, so we prepare a result, we'll eventually return the result. We initialize left, right, bottom, and 0, left and right on the row, top and bottom on the column. This looks good. We want to say while, let's think about this while loop, while left is less than right. That could be a red flag because that will be true in one direction, but you would think you would need a different condition in the other direction unless it's handled lower. And we're going to basically handle it lower because we're going to do a reverse iteration. All right. Okay. So get every value in the top row is from left to right. And then you go top to bottom. And you say bottom minus equals 1. Well, that seems strange because won't that make my bottom equal to a negative 1? Okay, and then our options for the problem, the code will fail to traverse the entire matrix, or the code will traverse the last submatrix multiple times. So I guess it's fine that bottom is traversing negatively because our iteration is also negative. So you get that double negative and then you're not going out of bounds, I suppose. All right, so let's consider this example 1, 2, 3. So I start at 0, 0 on the 1. For I in range left to right, yeah, left to right is going from 0 to 0, right? I think that's the issue. So I'm going to say it won't traverse the whole matrix because I think we need to initialize right as the length of matrix element 0 minus 1. Oh, that's incorrect. It will traverse the last submatrix multiple times. Problem with this code is it doesn't consider the case where the last submatrix is not square. If the last remaining part of the matrix is not square, the code will traverse that last submatrix multiple times. This is because there's no check to stop the bottom row and left column from being traversed again after the right column has been traversed and reduced. I'm not seeing it. In the above example, the output would be 1, 2. How do we get the 2? Oh, we get the 2 when we loop back through the whole while again. Okay, so I was thinking that this would go left to right, but this looks like a cell level iteration. I was thinking this was a row level iteration. This looks like a cell level iteration. Okay. What is its time and space complexity? So it's a cell level iteration, so it's m by n. And space looks like we're just, well, yeah, if you want to count result. Assume we include the output. Okay. Yeah, then they're both m by n, right? Yeah. Okay, cool. So that might be, and then it provides the video. That's convenient. So I might want to go double check on the boundary.
Hey everyone,
condition.
welcome back, and let's write. We just completed the row backwards. So now we're going to take each of these. The row is going to be I. That's what we're doing when we're iterating from bottom to top. The column is going to be the leftmost column. And after
right.
we've completed this, we are allowed to increment left by 1 because we just completed the entire left column. So we're shifting our left pointer to the right by 1. So this is the code. With these comments, it makes it seem a little longer than it actually is, but this code is not too long. Total, that is only like 12 lines of code, but if you want...
Makes sense to me. Cool. All right, we'll do one more. See how the chat is doing. What other platform are you using when going live? I use Restream. Shinra, thanks for the question. So I'll be using Restream, and I'll be streaming over to YouTube, Twitch, Twitter. I can do others, but I think those are the current ones. Sometimes I go to Instagram, not today. Let's do one more. To sum when the input array is sorted. Get unlimited access. What is this? I already have Pro, huh? I thought I already had Pro. Do I not have Pro? Maybe I don't. All right, so let's try to find one more threesome, one more that's not locked. Okay, given an integer array nums, return all of the triplet values ijk of nums so that the indices are distinct and they add to 0, right? So here's your threesome. Question is, what is the brute force approach to solving this problem? Time and space complexity. So the brute force approach would be for every value. Let's scan every JK pair. So I think it's n cubed. Yeah. How can we find the optimal solution by sorting? Okay, so we can sort it. That'll take n log n. Cannot help. C is out. C is out. Once we have that n log n, what do? We then apply to_sum in order. Okay? And the optimal two-sum, given that it's already sorted in the two-sum, is O of n, right? I think it's O of n. Yeah. So let's say that I have a complement. And then for each complement, I want to check what? For each complement, I want to check a decreasing window of j's and k's. So you still get j times k. So it's n squared. N squared dominates on the log n, so it ends up just being n squared. How can we ensure that our solution does not contain duplicate triplets? I would use a set. By checking if a triplet has already been added to a hash set. Fine, you don't even really need to check if it's, you can just replace it in place by skipping over duplicate elements in the sorted array. Yeah, that's smart. Do you want to do both of those? Yeah, maybe. I don't think you need to do both of those, but I probably would. Yeah. How does two-pointer help in eliminating duplicates? You can skip the duplicates, that's the reason. By skipping over duplicate elements in the sorted array, and also when choosing the first number in the triplet. I think this, what does C say? By checking the current triplet is already in the output before adding it. No, that's a different strategy. Okay? Given the optimized solution using sorting and a two-pointer, what is the overall time and space complexity? Didn't we already talk about this? Okay. So we have nums, we're sorting nums, great, but now we're enumerating nums. I don't think you need to do that, but all right. It doesn't add anything, it's an O of n pass. All right, so if it is, we already used nums I as the first element, so skip it. I don't like that variable name A, but that's fine. So that's the value we already used. We already used nums I. Yeah, I think even the comment is misleading. I would say we already captured all valid triplets for A. We already captured all valid triplets for A, so skip it. But that's fine. It doesn't change the complexity. We get the left, right, we get this nums, while left is less than, so this is the two-sum bit. Yeah, nothing here is different than what we already talked about, right? So it's still n squared. And the result is still going to have n. Oh, maybe we didn't talk about the space complexity. So we don't want to count the extra space result. I guess that's the idea. Yeah. The space complexity is 01 since we aren't using additional space other than the output. See, I call that extra space. That's fine, whatever. I would say it's O of 1 extra space, but it's still overall space complexity O of n, inclusive of the output array. I'm going to give feedback on this. This is still good, but overall space complexity is O of n in the optimized form, inclusive of inclusive of the output array. Because the input array is not utilized in place. If we want to evaluate only extra space rather than overall SC, the question should specify that. What's your favorite thing about programming? I like to be able to build things from my computer that can help lots and lots of people. So I think it's high leverage, high impact. It's relatively easy to get into. The compensation is great. The ability to work remotely is fantastic. All of these things, but if I had to pick one, I would come up with a phrase that encapsulates all of those things. So maybe I would say the potential for quality of life. I guess I would say that. Really, it's a bunch of things, but if I had to make it one thing, I would go for that. All right, chat, that's going to be it for now. I think this quiz feature is great. I think it does work as a warm-up before if you have an interview or something like that. See you next time.